So page 2 of our Unit 3 study guide requires us to do more graphing, but this time it's two equations, so two functions, two graphs on one coordinate plane. So let's start with graphing this first one here. We have y equals -4 times the square root of x plus 6. So I know I'm going to need my parent graph for the square root function. So 0, 0, 1, 1, and then 4, 2. So that's my parent there. And now we got to do our multiplier and our shift for this. So we have a multiplier of -4. We're multiplying the y values by -4. So this is at 0. 0 times -4 is 0. 1, this one's at 1. 1 times -4, this drops down to -4. And then our last one, the y value is at 2. So 2 times -4 is -8. And finally, we want to do our shift. So if we're looking at this, it's a +6 on the inside, so we're moving to the left 6. So all these points over 1, 2, 3, 4, 5, 6. So this one's a little off the graph. 1, 2, 3, 4, 5, 6. And last one, 1, 2, 3, 4, 5, 6. And there's our parent function for the first one there. Oh, sorry, not the parent function, the transformed function. Now let's get the next one going. So it looks like we have an x cubed function. And that one is going to be at 0, 0, 1, 1. We already got a point there. And then 2, 8. And I'll erase this, or I'll just cross this one out for now so we know we're not using it for this one because they're both in black. So -1, 1, and then -2, -8. So now let's do our multiplier. And we're looking at here, we don't have a multiplier there. There's not a number out in front, so we can just do a shift. Let's see, inside, it looks like we're moving to the left 2, and then we're moving down 8. So all these points, left 2, 1, 2, down 8, 1, 2, 3, 4, 5, 6, 7, 8. So here's our new point. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then the vertex 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Ooh, these are starting to overlap a little bit. This point here, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, right there. And then the last point was in here, but it got covered up because one of the points that we moved over overlapped it. But 1, 2, 1, 2, 3, 4, 5, 6, 7, and then a little off the graph, 8. So about right there-ish. And here is our other graph. Okay, so if we ask for what the solution is here, notice that they both share that point there. That would be the solution, but for now it's just asking you to put the graphs up there. Okay, let's do the next one. I'll try to do this one in different colors. I'll try to add purple into there. So if we're looking at the first one here, we have a absolute function. So we know 0, 0, up 1 over 1, up 1 over 1. That's our parent for our absolute function, and we have a multiplier, -4. So all the y values we're multiplying by -4. So the first one, 2 times -4 is -8. 1 times -4 is -4. 0 is 0. And then these are just reflected, or if you want to multiply them out. Right there. And if we're looking at it, there's no shift. So here is our final graph for the first function there. Now let's do the next one. And I'll put the parent graph of this one on in purple. So we're looking at x squared. So x squared is at 0, 0, 1, 1, negative 1, 1, and then 2, 4, and negative 2, 4. So there's our parent for a parabola, right? We have x squared, it's a parabola. And it looks like we have a multiplier of negative 2. And I'll do this multiplier in red. And now let's do it in green. So I'll do this multiplier in green. So from the purple points, because the x squared was purple, we have a multiplier of negative 2. It's out in front. We're multiplying the y values by negative 2. So this y value is 0. 0 times negative 2 is 0. These two y values are at 1. 1 times negative 2 is negative 2. So this drops to negative 2. This drops to negative 2. And finally, these two are at 4, the y value. So they drop to negative 8 and negative 8. So here is, now I'll do this one in green, our parabola. And notice that, again, we have those 2 points of intersection right there where they overlap. Okay, now the one on the left. It looks like we have f of x equals 6. So I'm looking at this one here first. F of x equals 6. I know that's going to be a horizontal line, so all the y values equal 6. So if I look at this 6, I believe it's this one here. Y equals 6 is this line going all the way across through 6. Okay, but notice now that we have a restriction here. So this is telling us that it only wants the points where x is less than or equal to negative 2. So less than or equal to negative 2. I go to negative 2, and I find where my graph is at negative 2. And I determine, do I need a closed circle or an open circle there? Because that's less than or equal to, I need a closed circle. So I'm going to put my closed circle here. That's for this graph, that's where x equals negative 2, right? Because that coordinate is going to be negative 2 comma something, negative 2 comma 6. And it tells me I want the values less than or equal to negative 2. So these here are the values that are less than negative 2, right? Negative 3, negative 4, negative 5, negative 6. So I want to keep those, and I'm going to erase these here. And now I'm going to look at my next one. I have an absolute value function. So I know my parent graph, 0, 0, 1, 1, 4, 2. And I'm going to do my transformation. I don't have a multiplier, but I do have a shift here. I'm going to be moving to the left 2. So all these points to the left 2. So starting with that vertex, left 2, over 1 over 2, over 1 over 2. So that's my graph there. Now we have restrictions, right? We want our graph so it exists within this region. So between negative 2 and 7. And at negative 2, if I'm looking at it, and I kind of jumped ahead here too, at negative 2, it's less than x. It's not less than or equal to, so we should have put a open circle at negative 2. So this requires an open circle. And we want it all the way up to 7. But if we look at 7, we don't have a value here. So what we can do, real quick, we can if we want a value for 7, we can plug 7 in. So this would give me the square root of 7 plus 2, which is the square root of 9, which is 3. So if we plugged in 7, we got 3. So we know that at 7, we get 3. And then do we need an open circle or a closed circle there? Because it's less than or equal to 7, it's a closed circle. And we have enough information to draw our graph accurately. So there it is, existing between -2 and 7. All right, next one. So this one has 3. So let's do all of these. First one we're looking at f of x equals -x, where x is less than 0. So the parent function for x, that's just starting at the y-intercept, and then up 1 over 1, up 1 over 1, and the other way as well. Okay, so that's a linear function. If it's just x, it's a linear function. We know we have a line. The rate of change has to stay the same. So we do have a multiplier, and it's -1 that's out in front. So we got to flip this or multiply the y values by -1 right here. So if I multiply all these y values, this is the y value here, 0. 0 times -1 is -1. At this one here, the y value is 1 times -1 is -1. That's right there. So this all just flips. Okay. And then I look to see if I have a shift. I don't have a shift, but let me get my line tool so I can draw a straight line. All right, but now we look at our restriction that's here. It tells us that we want x less than 0. So now when x is less than 0, so let's go to 0 and then determine what kind of point we need, a dot we need. Do we need a closed dot or an open dot? If we go to 0, it looks like we're going to need a open dot at 0, so I'm going to need to do some erasing. So I'm going to erase this. I know at 0 I need a open dot. Okay, and I want the values less than 0. So here is less than 0. I want to keep those, so I'm going to erase or cross out. We are going to want to see your work, so we want to see this crossed out. But to keep it clean, I'm going to erase where it's greater than 0. And this we can extend as well. Okay, now let's look at the next one. We have y equals x between 0 and 4. So y equals x between 0 and 4. We know we start at the origin and then up 1 over 1. So we already have the parent for this on here. And now let's draw our line. So we want it from 0. So at 0, we're going to need an open circle. So at 0, we need an open circle. And then at 4, we also need an open circle. So it looks like we need to draw this out a little more. And at 4, we said we need an open circle. There it is. So if I use my line tool, and I only wanted it from 0 to 4, that's what it looks like. And I don't need those 2 points here. Oops. I don't need these 2 points here because our graph doesn't exist less than 0. So it's only there from 0 to 4. And our last one, our x squared, and I'll do this one in blue. So I'm going to get my parent graph for x squared on here. try to be as least disruptive as possible to all these other ones. Okay, so there's my parent graph for x squared. It looks like we do have a multiplier, right? We have a multiplier of -1, which means that all those points are going to flip down. So I'm going to erase these and flip them down this way. And again, just so I can keep it clean. And I'm going to do my shifts. So my shifts look like it is moving to the right 4 and then up 4. So all these points, right 4, 1, 2, 3, 4, up 4, 1, 2, 3, 4. So I have a point there. 1, 2, 3, 4, 1, 2, 3, 4. Right there, and if we keep doing this, we should get that graph there. Okay, so now before we draw this in, if we look at our restriction here, our restriction said that we want the values where x is greater than or equal to 4. So where is x greater than or equal to 4, we are going to need to put a closed circle. So at 4, our graph was right here. And then we want the values greater than, so it's these here. And we can erase it, and this would go on as our parabola goes. Okay, so looks like it's continuous. So if we follow this, we don't have to lift our pencil. It goes all the way through.